Dear friends, in this video, we will look at another interesting problem in integral calculus, which is part of our series, my series, Algorithmic Thinking for Mathematics. It's an interesting problem. Let me just do that. Gaussian integral problem statement. Evaluate integral minus infinity to plus infinity e raised to the power minus x squared dx. How do we do this? Very interesting problem. Let me look at the solution now. Solution part. If we define I is equal to integral over the domain minus infinity to plus infinity, e raised to the power minus x squared dx, I is also equal to minus infinity to plus infinity integral e raised to the power minus y squared dy. And therefore, when I multiply I with I squared is equal to integral minus infinity to plus infinity e power minus x squared dx multiplied by integral minus infinity to plus infinity e power minus y squared dy. Since the integrand is non-negative, the product equals an integral over the real space R squared. I squared becomes a double integral over the domain minus infinity plus infinity minus infinity plus infinity e raised to the power minus x squared plus y squared dx dy. Change them to polar coordinates by substitution. X is equal to r cos theta, y is equal to r sin theta, so that x squared plus y squared is equal to r squared. Because cos squared theta plus sin squared theta is 1, x squared plus y squared becomes r squared. Now, we have to find out the Jacobian of the transformation r theta from xy. Jacobian of the transformation r theta based on xy. So we need to find out the partial derivatives. D delta x divided by delta r is equal to cos theta. Delta x divided by delta theta is equal to minus r sin theta. And I differentiate. Delta y by delta r is equal to sine theta. Delta y by delta theta is equal to r cos theta. How do we get the derivative? X is equal to r cos theta, y is equal to r sin theta. That's all. So you find out the partial derivative with respect to r and theta, you get this matrix. Once you do that, find out the determinant. The Jacobian J is the determinant of cos squared theta minus r sin theta, the first row, sin theta r cos theta in the second row. So let me repeat it again. The determinant J is equal to cos theta minus r sin theta in the first row, and the second row of the matrix sin theta comma r cos theta. So when I evaluate the determinant, this will be equal to r times cos squared theta plus sin squared theta, which is equal to r. Because cos squared theta plus sin squared theta is equal to r. And therefore, dx dy or delta x delta y, dx dy is equal to the Jacobian multiplied by dr d theta, which is equal to r dr d theta. So, substituting in the polar form, the domain of r is 0 to infinity, the domain of theta is 0 to 2 pi, and therefore I squared, which is a double integral, is 0 to 2 pi integral 0 to infinity e raised to the power minus r squared r dr d theta. Evaluate the inner integral with the substitution u is equal to r squared, and therefore du is equal to 2r dr. Therefore, r dr is du divided by 2. So the inner part of the integral 0 to infinity e raised to the power minus r squared r dr is equal to half 0 to infinity e raised to the power minus u du, which is equal to half. Now, I squared is therefore equal to, you come to the outer integral 0 to 2 pi half d theta, which is equal to pi upon evaluation and substitution, and therefore I greater than 0, therefore I is root of pi. And this is the answer. The interesting part is when you look at the standard normal distribution, which is from the domain of minus infinity to plus infinity, e raised to the power minus x squared by 2 divided by root 2 pi, it is easy to prove integral minus infinity to plus infinity e to the power minus x squared by 2 dx is equal to root 2 pi. The same logic, we can do that, and that is the power of this Gaussian integral, which is applied in the standard normal distribution for the evaluation of probability for various values of the random variable, which is standard normal in x, which is to say x is normally distributed with mean 0 and standard deviation 1. So this has the application there. But incidentally, I just wanted to mention, otherwise we are through with the solution, a magnificent problem, I is equal to root pi. Thank you very much. We will see you soon in another video. I hope you have enjoyed the video.